All right, so you can see it's charging. Current is stripping down because this battery was fully charged before it was sent out. Okay, now 100%. So we've wired the connection to the output. Okay, so I will turn on the inverter now. So the inverter is on right here. The AC is on and is on L1. So let's say 12 noon. Okay, so this is the idle consumption of the inverter and the AC. So the AC will kick in now. So you can see we are consuming 43 watts. As small as this battery is, we are pulling 1000 watts. We are pulling 1000 watts from the battery. This is showing overload. The AC keeps ramping up, and you can see this is like a stress test for this. So we are doing 1 kVA. Let's see the load. So you can see 800 watts. Okay, so it's showing this 800 watts thereabout. Okay, and this keeps increasing. So 84 amps. Okay, so let's reduce the AC a bit. Okay, so the power is reducing now. See, 1000 watts from the battery, 80 amps. That's almost 1.5 C. About 6 minutes into the tests, we have drawn 4.5 amp hours. Okay, so this is the power of lithium batteries. We can do 80 amps from a 50 amp hours battery. Still showing overload. So battery voltage is still at 12.7. If you do this on a tubular battery, then you will have almost a shutdown. So the power consumption is reducing because I increased the temperature. 10 minutes into the test, you can see we have done about 10 amp hours. On the DC side, we are drawing 800 watts, but on the AC side, we are only getting 650 watts thereabout. Okay, so that's conversion efficiency. And some will say, oh, you are discharging a 50 amp cell at 62 amps. I even did 80 before now. So you can see, let's look at the temperature of the cell. The cell temperature has increased to about 28 degrees. So in here I have about 26 degrees. For testing this, you can see the cell temperature is rising because we are doing about 1 C. The temperature will keep increasing because we are doing high discharge tests. Okay, so that's just it. So about 600 watts now. We are drawing 730 watts from these little batteries. 160 watt hours times 4 will give us 640 watt hours. Okay, so the nominal voltage for this battery is 12.8 now because we are doing 4 in series. So if you divide this by 12.8, we should have what, 50 amp hours. So that's why we are testing for 50 amp hours here. 24 minutes into the test now, so we have done 21 amp hours. We are discharging at about 1 C. So expect the temperature increase. So you can see 32 degrees now on the battery, which is still very good. Okay, so you can see 31 degrees, 12:55 p.m. and we have done 44 amp hours. Now you can see our battery is still way above 12 volt and we have gotten 44.6 amp hours. So set temperature has increased to about 35 degrees there. So we are doing 1 C discharge. That's a lot of power coming from these cells. We have hit exactly 12 volts. Okay, so at exactly 12 volts now, where we recommend you to cut off, you can see we have done 99% of the battery capacity is already gone. If you stop discharging at 12 volts, okay, most people will cut off at this 12 volts and stop discharge. So you can see capacity we have done here is 49 amp hours. So you are able to discharge all the battery capacity if you cut off at 12 volts. All right, so good, 50 amp hours. So you can see now that this battery is rated 50 amp hours and we have gotten the 50 amp hours. So that is correct. So you are able to discharge all the battery capacity. So you can see the battery temperature increased to about 35 degrees because we are discharging at 1 C. Okay, so the battery alarm has the that's from the inverter. So we done 51 amp hours at 10 volts, meaning we have 2.5 volts per cell. So, okay, so that's it, 51.1 amp hours. Great result. So you can see the voltage has bounced back to 11 volts and is going back up. So you can see this is the final capacity, 51 amp hours. So I'll test one after the other. So start with the overall. So you can see overall is 11.6. The first one, okay, 2.96. The second one, 2.92. The third cell, 2.92. And the fourth cell, we have 2.89. Okay, overall voltage again is 11.7. All good. So that's it.